Hi everyone, today we're going to start Unit 4, Chemical Reactions. So just as a heads up, a lot of the things in Unit 4 are going to serve as a review. We're going to review a lot of things like physical and chemical changes, physical and chemical properties, and we're going to go over kind of how to write reactions, but we're going to be adding more details as we go throughout it, and there's going to be some reactions that we haven't familiarized ourselves with before, and so we'll spend a lot more time doing that, but just as a warning, a lot of this is review. Now first, just a little review about our classifications of matter. Of course, up top we have matter, and then as part of matter we can either have a heterogeneous mixture if it's non-uniform throughout, or we can have something that's homogeneous if it's uniform throughout. If you look at one part of a particular substance, it should look like every other part. If it has variable composition, then of course that's when you have a homogeneous mixture or a solution, which we talked a lot about in our last unit. Otherwise, you'll have a pure substance. And of course, those can be either elements or compounds. We spent a lot of time so far talking about homogeneous and heterogeneous mixtures and how we can actually separate those using techniques such as filtration, distillation, or chromatography. Right, those are our main methods of separating mixtures, but when we get into reactions, we're thinking much more about how we can actually obtain these mixtures or how these mixtures potentially react. Now, whenever we have a substance or a mixture, there are two different properties that we can use to describe it. The first are physical properties, and these can be observed without changing one substance into another, right? And so you're not undergoing any sort of chemical change in order to observe a physical property. And so some of these things are like color, odor, density, melting point, boiling point, and something like, malleability or ductility. Right, and so you can observe all of these without having to do a chemical reaction, without having to change your substance. These are just innate properties of a substance. So, chemical properties, on the other hand, can only be observed when changing one substance into another. So some examples are flammability, which is, ability to burn in the presence of O2. Right, and so if you have something that's flammable, that can burn with O2, but you only know that when you change a substance into another, or a reaction happens. Now, other properties of any kind of a substance that you may or may not have heard before are intensive properties. These are independent of the amount of a substance. So these are things like density, boiling point, and color, for example. Right, if I have any sort of material, if I have 1 gram of CO2 versus 1,000 grams of CO2, its density is always going to be the same. Its boiling point is always going to be the same. And this is important for identifying compounds. And so if I, have a mysterious substance and you tell me its boiling point, I should be able to figure out what that substance is, given the boiling point and maybe other information like color or density. The other property that we're going to talk about are extensive properties. Now, if intensive is independent of the amount of a substance, extensive are dependent on the amount of your substance. So for example, things like mass, volume, or even energy. Right? All of these will depend on how much of a particular substance you have. Now, of course, we should have all seen these at some point as well, physical changes. These are changes that do not result in a change of chemical composition. And for the purposes of this class, really, when we mostly see this is changes of state. Right, and so solid versus liquid versus gas versus aqueous. And so, for example, dissolving salt, right, that's just a change of state. At the end of the day, you still have sodium chloride. Same thing with ice melting into water, right? You still have 2 hydrogen atoms per 1 oxygen atom. And so for our purposes, physical changes are typically just a change of state. You don't have a change in chemical composition. Chemical changes, on the other hand, result in a change of chemical composition. And so some examples are like combustion, otherwise known as burning with O2 gas. You have oxidation, which we will talk about a lot more when we get into redox reactions. You have something like decomposition. All of these are examples of chemical changes, but it's when you have a change in your chemical composition. One example of oxidation that we actually have already kind of covered was in our lab on brass, right? If you take nitric acid and a copper penny or any source of copper, what will happen is you'll oxidize it. And so you end up going from copper solid to copper 2+, and you also lose some electrons. We'll talk a lot more about this when we get to the oxidation and reduction chapter, but just as a kind of aside, we've already seen this a little bit when we take a metal and turn it into an aqueous solution. So this would be aqueous right there. Now, there's a few key bits of evidence that show you that a chemical change is happening. The biggest one that I want to point out is precipitation. Right, and precipitation is when solutions mix to form a new, I'm going to underline new, solid compound. An example of this, which we may have seen before from previous exams, is right, silver nitrate, AgNO3, mixing an aqueous solution of that, mixing with an aqueous solution of sodium chloride or salt. When those mix, you get AgCl, which is a solid, and so that'll precipitate, and you'll also get sodium nitrate. And this dissolves, and this is still aqueous. And so that's an example of one way you can tell that a chemical change has occurred. Some other, dead giveaways are color change, light production, temperature change sometimes, sounds very rarely, but occasionally sounds can mean a new chemical change has happened. Production of gas, not a change in state from liquid to gas, but a gas being produced, similar to precipitation where solid is produced. And then formation of substance with new properties. One helpful thing to always remember, kind of relating this back to our last unit, if you are breaking bonds, that is chemical. Right, if I break a hydrogen-oxygen bond or break a carbon-carbon bond, that is a chemical change that's occurring. If I break IMFs, that's physical. Right, and so if I have two substances that are held together by London dispersion forces, or if I have, like H2 gas, which holds itself by London dispersion forces, those LDFs break each other apart, then that is a physical change. Or for example, in solid water, right, in ice, all of those water molecules are hydrogen bonding with each other. If I heat it up, those IMFs end up kind of breaking a little bit or becoming further apart, and then you get liquid water, and that'll continue on to gas. So if you break bonds, that's chemical. If you disrupt or break IMFs, that's physical. We'll talk a little bit more about this in class, but for now, that's all. Thanks.